Equivalent fractions. 3 friends each have 12 sweets. Abby puts hers into 4 piles and eats 2 of the piles. So she has eaten 2/4. Libby puts hers into 2 piles and eats 1 of the piles. So she has eaten 1/2. Missy puts hers into 6 piles and eats 3 of the piles. So she has eaten 3/6. They all eat 6 of their original 12 sweets. So 2/4, 1/2 and 3/6 look different, but they're the same fractions. They are equivalent. Let's look at how we can expand fractions. And we get different ways of writing the same number. So here I have 1/4 or 1/4. And what I'm going to do is divide each part into 2 small parts. So here I have, instead of 4 parts, I have 1, 2, 3, 4, 5, 6, 7, 8 parts on the bottom. So that will be 8. And on the top I have 1, 2, so that will be 2 8s. And we can see how we get from one to the other. What I'm going to do is multiply both the top and the bottom by 2. Now when I do this, 2 divided by 2 is 1. So when I multiply 2 by 2 over 2, I'm really multiplying by a big 1. I'm not going to change the value or the size of this number, but I will change how it looks. It looks like 2 8s, but 2 8s is the same as 1/4. I could split 3/4 into each into 2 small parts. So here again I have 8ths on the bottom, but on the top I have 1, 2, 3, 4, 5, 6 8ths. And here I am multiplying top and bottom by 2 to get 6 8ths. Still multiplying by a big 1. We can try this with a different number on the bottom. I can have 3/5 divided into 2 small parts. Then I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the bottom. And on the top, 1, 2, 3, 4, 5, 6. So this is 3/5 multiply top and bottom by 2 to get 6/10. But I don't have to make it 2 here. I can split it into 3 parts. Here I now have 3, 6, 9, 12, 15 parts on the bottom. And on the top, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 parts on the top. And again, I can write it as 3/5 is 3/5 times 3 over 3 times a big 1, which gives me 3 3s are 9 and 5 5s are, and 3 5s are 15. 9 15ths. I can rewrite it as, now I have 4 5s are 20 bottom, and 4 3s are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 on the top, and again the same idea applies. And we can write fractions in as many different ways as we wish. So we can go the other way and simplify fractions. 12/18 is a perfectly valid fraction, but I can't imagine in my mind a cake divided into 18 pieces and having 12 of them. It doesn't give a very immediate mental image to me. And we can get a better mental image if we have a smaller number of pieces that the cake is divided into. So maybe I can group these parts together. Maybe I can group them together into 2s. Then I will get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lots of 2 in 18, and also 1, 2, 3, 4, 5, 6 lots of 2 in 12. So I can reduce the fraction, I can simplify it. This now becomes 1, 2, 3, 4, 5, 6 on the top, and on the bottom we have, click in just the right place, 9. So this is the same as 6/9, and we can write it in maths language by dividing the top and the bottom. Here these numbers are getting smaller, so we're dividing by 2 on both the top and the bottom. If you think about this, we're really dividing by 2 over 2. And 2 divided by 2 is 1. We can divide any number by 1, and we don't change the size of it. We do, however, change how it looks. It now looks as 6/9, and I can more easily get an image in my mind of what a cake divided into 9 pieces would look like, and having 6 of them is a bit better, but maybe I can improve on this. Maybe I can group them into 3, and we can see that here we can indeed, because 3 divides into both 18 and 12, and we get 1, 2, 3, 4 groups out of 5/6. So this should be 4 and exactly, where do I click here? Thank you. 4/6. And again, I can show you this as being divided by 3 on the top of the bottom, and 12/18 is 4/6. But maybe I can do even better. How about 4ths? Well, here we can see if we're grouping them into 4, we can get the 12 grouped into 4, but not the 18. 18 is not divisible by 4. But we won't stop here. Let's try groups of 5. No, that's not very useful for either, but groups of 6. And here we're doing very well indeed. 6 will divide into 18 and 12, and we can see we're going to get the most simple version of 12/18 by doing this. We have 2 groups on the top and 3 groups on the bottom, so this is 2 thirds, and we could find this by dividing top and bottom by the largest number that will divide into both 12 and 18. That's the lowest common the highest common factor of 12 and 18. 6 is the largest number that divides into both 12 and 18, and we can see that 12/18 is 2/3, and I have a simpler fraction. I can't always simplify. If I were to change this to 3/7, for example, then there is nothing I can do to break this up. If I try splitting into 2s, nothing goes into 7. In 3s, that doesn't go into 7. And 4, well, that would be 2 4s are 8, so I'm stuck there entirely. So 3/7 will not simplify. If I were to change this to 3/6, then I can group them together into 3, and we will see we have these 3 become one group and these 3 become one group, and we can simplify this off to 1, up, and we can write it dividing both by top and bottom by 3 to get 1/2. So find the biggest number that will divide into both the numerator and the denominator. In this case, this is 3, and that's how we simplify fractions. So, if we're trying to find out if fractions are equivalent, we simplify the fractions. We look for a number that will go into the top and bottom of the fractions, the biggest we can find. It's called the highest common factor, HCF, or we just do it repeatedly. So, and then divide top and bottom by the highest common factor. So both 8 and 24 can be divided by 8, both 12 and 36 can be divided by 12. So if I divide top and bottom, well, dividing by 8 over 8 is the same as 1, because 8 over 8 is 1. So I call these big ones, and I can do this without changing the number. So 8 divided by 8 is 1, 24 divided by 8 is 3, 12 divided by 12 is 1, 36 divided by 12 is 1. Both of these are the same, so these fractions are equivalent. You can't find the HCF. See if you can find a big number that divides by looking. And there's some tricks we can do. If both numbers end in 0, then 10 divides both. If both numbers end in 5, then 5 divides both. If both numbers are even, then we'd certainly divide by 2. If it simplifies once, try again. How about 3? Well, add up the digits of both numbers. 18, 1 plus 8 is 9. And for 27, 2 plus 7 is 9. Now, if we add up the digits and it's divisible by 9, then the number is divisible by 9. If we add up digits and the number is divisible by 3, then the number is divisible by 3. So in this case, both of them are divisible by 9, and 9 divides both. So I can divide by 9 over 9 and get 2/3. If they'd just been divisible by 3, I could have done it with 3 over 3. And you can also recognise 11s from 11 times table, 22, 33, 44. So are these fractions equivalent? Simplify the fractions, look for the highest common factor. That's going to be 2 for 8/10, and it's going to be 4 for 12/16. Divide top and bottom. 8 divided by 2 is 4, 10 divided by 2 is 5, 12 divided by 4 is 3, 16 divided by 4 is 4. These are different numbers, they're not equivalent. 9/12, well, 3 will go into both. 21 28, you need to know your 7 times tables, and that's divisible by 7. So 9 divided by 3 is 3, 12 divided by 3 is 4, 21 divided by 7 is 3. 28 divided by 7 is 4, and they are the same, so the fraction is equivalent. So what number goes here? Well, we've got to look. What am I going to divide 20 by to get 4? And that's going to be 5. So I've got to do the same on the top. And if I divide 15 by 5, I get 3/4, or 3 and then 3/4. This one, well, what have I divided 32 by to get 4? And that's 8. So I divide top and bottom by 8, and 5/8 are 40, so that's 4/5. Here, I'm looking here, I've got a bigger number, so instead of dividing, I must be multiplying. And 24 divided by 3 is 8, so 3/8 are 24, and then I've got to multiply the top by 8 to do the same at top and bottom. It's multiplying by 1, I get 16/24. Here, multiplying by 9 on the top, so the same on the bottom, I get